Musica.
What time is it? Oh, it is 6 o'clock. Anyway, welcome. Last week of class. And yeah, I guess, yeah, I saw your reflections and, your, it was about the finals and all. By the way, those of you who want to take a retake of the midterm, you have to request it. Yeah. And I did say, I promised that, but then I think you have to have done really awfully, like, yeah, like 50% or less. So you can't say, well, I got 18 last time. I want to try and ace it this time. I want to retake. No, that's not possible. Yeah. So if you think you did a really bad job, absolutely another chance. Anything else? We got a few minutes before we start, really. It's only 6:02. So if you have any questions, happy to address them now. Yeah, Richard's holding something up, Raspberry Pi or something.
Yep.
Oh, it's a Raspberry Pi.
Yeah. So I got a job this week.
Yes, yeah, and yeah, thanks especially to Richard, who because last week I said that well, the minimum requirements for passing the class is this, and so even though he's passed all of that, and he's got a job, he's still attending class and participating in the Reddit and all. So thank you guys, especially everybody who's stuck around in the class and essentially attending the last week and as being engaged with the material in week 11 and 12 when there's so much competing interest for your time. right? Even excluding entertainment, because all of the classes have their finals and all of these things, and commencements and graduations and all these crazy things happening at this time. So this is the time that professors could actually look out for. Okay, what is that student spending the most time on at this time when everything is actually taking up their interest? Yeah, so I'm happy to see all of you, actually engaged in doing stuff, just, hacking around. Ultimately, that's what it is. Great stuff is ultimately stumbled upon by people who hack around. Okay, I think that is my, I don't know if there's a theoretical backing to it or anything, but I think a lot of great stuff is basically found. Even in your own search for algorithms and clever ways of doing things, even if you read up on how other people have come across these incredibly subtle but beautiful algorithms or mathematical proofs. So I don't know. At some point, I guess you are also going to be wondering and pondering. And I my what I can see is that it's just hacking away repeatedly, right? Just in that area, you go in the neighborhood and start walking and walking and walking, and you stumble upon these things. But then, because you're just walking with no agenda, you can actually recognize awesome stuff when you come across it. Because most of the time, in everyday life, what I find is, especially students, there's so much awesome stuff that comes their way. Okay, maybe as being on that side of the fence, I can actually recognize more easily. Yeah, there is a lot of stuff that's coming, but the students don't seem to see a lot of that value, and I think it's because they're moving fast. Okay, lots of things that are are just a blur at high speed. I think so, right? So I think that is why I think it really helps to just take a couple of subjects, right? A couple of subjects and say, this is basically what I want to focus on. And so I'm just going to keep on noodling away, doing a game, doing a server, all these crazy things, whatever, doesn't matter, even if nobody else does it. So you do it and play around, and ultimately you will be doing that automatically, but your mind will be primed to say, hey, something was very clever in the way that happened, that cookie crumbled. And okay, so you latch on to that. So many things happen, but we don't see them. But then if your mind is just ready, like, I think a lot of ancient civilizations have this saying, when the student is ready, the teacher will appear. Yeah, the truth behind it really is that there are teaching experience all around us all the time, but we just don't see it because just we're moving fast. So we just slow down a bit and see what's there. You will actually find a great deal of stuff. I think that is how programming also works in a lot of ways. So I greatly encourage you all to, even if nobody else is engaged, just do solo projects. This is week 11. And after this, you got the summer break. Yes, that's basically it, isn't it? Two months. Yeah. So this today and Thursday is the last time we will meet, because I don't think I'm doing 2B and 2C, face to face for the rest of my, until I retire. And I'm not planning to teach after I retire, obviously. So yeah. So this is the last. So I want to make sure that I find so I give you my most valuable 2 cents, whether it's really valuable or not on your end, is really that these 2 months are so valuable that everybody's going to just suck it out of your hands. Okay, so you just be mindful of that and say the entire 2 months I'm just going to focus on one personal development. That's maybe 24 hours a day and 7 days a week, doesn't matter, but every waking hour I'm just going to devote to that one skill, and I'm going to repeat that so many times so it just becomes second nature. And that's all I have at the end of 2 months. But at the end of 2 months, it's just I got a new earned a new superpower, okay, in game parlance, which you can use at your will anytime in your life. But you got to put the effort to gaining that skill. Okay, and that is just going to be a lot of hard work. But you got to have faith in yourself and just keep at it, I think. So, in fact, even though I'm not, well, you're going to be doing 2B, you can do my 2B quests, okay? Even if you're not doing my 2B, you do all the quests and 2C quests too. And there are people who are able to help you, okay? There are lots of people on the forum who will be able to help you. They've done the red, blue, and green quests also. So it's all available. So. All right, that's all I have to say. That is my spiel before we start. Well, we got a couple more minutes. Okay, a couple more minutes. Well, how about anybody has a question? Anybody else wants to say something? Go for it now. We'll start at 6:10. Okay,
Hi,
6:10.
Professor.
Who is it?
Hi.
Hey, Mark. Yeah. Hey,
Yeah,
by
I
the
was
way,
wondering.
were you the one who put up that Amazon page?
What?
There was an Amazon page that was shared on screen.
That was me. That was me, Rick Kramer.
Oh, yeah. So what was that? Is that the Absolute C++ book?
That's the book for the class. It's $170, which I
Yeah,
don't.
yeah. No, but there is a free version of the book, a PDF. And I think I don't know if it's pirated, but it is because I think it's hosted at some university. So maybe it's an author gift or something like that. But it's a second edition. But who cares? We're after the basic syntax here. We're not talking about the most latest C++ developments about smart pointers and things like that. Yeah. So the core of C++ I don't think has changed since the second edition, and the second edition is free. So why would you pay? And plus, who buys a? Is that are you talking about the physical book, Richard? That's this thick.
Yeah, 170 for the book.
Who actually buys them other than libraries? Because who would actually get? I don't know. Maybe there are people who buy them, but ideally you would get an e-version on an iPad because at least it gives you good seeking and search rather than going to the index and all. But anyway, that PDF is free. So many people have linked to it.
If you find a link to it, could somebody put it on the chat so I can get it? I want to I think I did really poorly during this class, and I want to study in case I need it later.
Okay, if you want to do, all right, here's my suggestion. Okay, the Computer Science Club has a distillation of the essential topics from that really fat book, and it's called the Michael Losef modules. Have you heard of them?
No.
Okay, the Michael Losef was a previous teacher, the previous teacher of CS, the C++ track at Foothill. Okay, he retired the year I joined, and I think Lane is taking over. I think the C++ track after I retire. So it's a continuity. So in fact, all of our most of our, well, let's say 75% of our topics essentially are are identical to Michael's milestones. So he had the 12 milestones for 12 weeks, and that's basically what we do. Yeah. And I might have accelerated a few and shuffled a couple around, but essentially that's what we're doing. And but if you're doing the final, all 12 are covered, and they're roughly the same order. And I think Caitlin or someone posted a link at some point. She actually, Caitlin posted a full web page of tons and tons of resources for the final.
Yeah, she really helped out for the midterm.
Yeah, I'm pretty sure she has a link to the Computer Science Club notes. Okay, so Computer Science has all of the Michael Losef notes. So just go to the C++ notes, and they are, I think, your staple for the final exam.
Yeah, Kaylin posted on the chat. Thank you, Kaylin.
Good question, Richard. Okay, that nobody should feel antsy about the final at all. Okay, and I think anybody who has crossed quest number 6 can assume they've actually passed the class. Okay, if you do get a failing grade, you just email me saying there must be an error. Okay, so everybody would have passed the class. Everybody who stuck around and attending class at the last minute, the last week, and actually participating in the Reddit, they all of that counts for things. Okay, in your participation and all the other scores. So you don't have to really worry so much. So I want everybody to go into the final just feeling that it is a chance for you to figure out, it's impossible for the final to ask me a question that I don't know. Let's see what it's got. Okay, that kind of attitude, because you don't really, if you totally screw up, just send me email and say, I want to take it again tomorrow. And I only finalized the final scores, I think 2 days later. Thursday, Friday. Yeah, I finalized the scores on Sunday. So you can actually email me and you can do a retake. If you did a awful job on the final, just like the midterm. Okay, so nobody should be stressed out for the final now. Okay.
So I had a question.
Mhm.
Like, I was wondering, is there any like extra credit opportunities?
Yeah, well, actually, you know what? Now it's too late for extra credit activity because it's only one more week. But you're done with question number 3, question number 9, are you?
Yeah, like some weeks ago.
Oh, I see. Okay. Well, if you asked me last week, I would have probably come up with a good idea. All right, let's see. All right, let me think about this. Because does it have to be C++ or okay, do you do Swift and iOS or Android projects?
Oh, I said it's just limited to C++. So that's what I'm looking at.
You can count my blackjack program if you want.
Also, like I did one today.
All right. Well, anyway, let's not talk about those things now, okay? We'll just focus on the final and stuff. And for extra credit, I think what you can do is really just create a kick-ass Reddit profile for yourself. Come up with interesting things. More Mandelbrot pictures, animations, whatever it is. Spark up interesting conversations. Ask interesting questions. Those things will actually count as extra credit. Not just for participation. Does that make sense?
Yeah.
Okay. You can also take up any of the topics that were responsible for a particular animal in that quest, right? So you say, hey, you know what? Quest number 9, we did this, the following things with linked lists. Okay, why did we do it that way? I did some digging around, and this is what I found. Anybody else got some thoughts? Okay, and the important thing is to just have a back and forth. It is not important to be right or wrong at all, or even efficient or inefficient. It's say, well, this is a problem, and that guy says, hey, well, hey, if that's a problem, we can solve it this way, maybe using some inefficient algorithm, right? And then you say, well, that algorithm can be improved this way, and more. It's basically iterative. So no particular algorithm is the right algorithm ever. But you just say, recognize the problem, but here's a way to solve it, right? But the solution has more problems. Well, not more, right? Less, still has problems. And basically just whittling it down. It's kind of like a sort method. So you can draw all these insights from the algorithms you're implementing with the stack. And also you can talk about the advantages and disadvantages of creating an array-based stack using a vector, which is what you have to do in quest number 8, versus a heap-based stack that we did in class. Yeah. And the code is like super duper simple, but there are certain things much easier and faster with an array-based stack. So those are things that you can actually talk about, and you can do experiments. Okay, so and talk about extra credit. You can do an experiment and saying, hey, you know what, which is faster? So I took the heap-based stack, and I've got the array-based stack here, and I ran some experiments where each one of them was, I pushed a million numbers and popped a million numbers, and these are times it took, using clock, right? And, for 10,000 numbers, 100,000 numbers, a million numbers, and produce a graph using, and all of those interesting experiments, not just for this class, but I think if you publish those things on Reddit, those will also be very, very good things to link into your essays and when you apply for colleges. I say, this was an experiment I did because I was curious about which one of these would actually be faster. They provide the same functionality, and they're both linear in time. Yes, they're both linear. So one is not quadratic, one doesn't take n log in time or something like that, right? They're both linear in time. Well, you will cover about, we'll cover things to do with linearity and those things more in 2B. What I mean is they're both about the same level of complexity, but still we find that one is faster than the other. Why? Okay, I think that is a super duper interesting, conversation. That could essentially just even happen on Stack Overflow or some of the other societies, and there will be lots and lots of people chiming in. And so if you come up with a very good, timing graph and an article here, and just cross-post it there, and you'll attract a lot of very interesting discussion around it. Now, I would be very keen to see and read these things, essentially. Saying, hey, you know what, they went and did an experiment. I'm actually very curious to see what happened, right? And if if you're looking for experiments, essentially, what can I run to find out, do an empirical test? You can ask me, I can brainstorm with me, and I can come up with, and if they don't, it'd be extra credit. If not for this quarter, it may be for, if you enroll in my 2B, we can consider that as some kind of extra credit for 2B also. So yeah, all of these are possibilities. I don't see CS2A as one course, okay? Although people may basically opt out after CS2A, but I don't see it as one course. I just see it as the prep to going to CS2C. If someone's done CS2C, then I would actually trust their instincts as a programmer, but not, not completely trust. But you have much more ground. Well, after you finish CS2C, you'll know, right? Because what happens is that there's a certain kinds of errors that you just have to face enough times so that you don't make them. And so the frequency of those errors drop off with the more times you face them yourself. And by the time people are done with 2C, they would have faced those errors so many times, they don't encounter them anymore because they just step around them. So people who haven't faced that level of errors, they're a lot less productive because they actually run into real errors when they code. And they have to debug them and figure out what the hell is going on and so forth, right? So that is why all these are problems. Even if you take math books, right? So people say, at the end of the chapter, there may be like 500 problems. I know, keep increasing with every edition, right? And people often say, I just have to do all the odd numbered ones or prime numbered ones. But no, you have to do every single one of them is to develop the math sense, not to know how to solve a particular problem. Even though I know that I have to, take the second derivative and so on, I look at the sign and so on and so forth. It's not like 5 problems, but after doing about 10 or 15 problems, you get an instinct, intuition about why that is. Yeah. It just happens after a certain, you're putting in the certain number of hours, like the 10,000 hour rule or whatever it is that it's called, right? This is like blind faith, really, saying if I do it, I'll get it. So I hope that every one of you will invest yourselves with, even if you're not doing my CS2B, just start doing the quests and progress all the way to 2C, okay? And I will be happy to help if you're absolutely stuck in any of these quests, leading all the way up to red. I'll be happy to help you, right? As long as I'm, still not retired, until the end of next year, or this academic year, but 25. Yeah, so I'll be happy to help all of you. Yeah, but you'll have seniors all the time, right? Even people who've done this before and so on, they'll all be there too. So and it's going to be fun. I'm very happy to see such a big crowd. Good turnout in week 12. Really, or maybe I've just been very pessimistic about the turnout in week 11, because last year it was like dismal, like 1 or 2 students showed up. So thank you all for showing up today. All right, I think you should switch on your camera too. So this is my plan for today. Okay, what time is it now? Yeah, 6:20. Oh, wow. Okay. So we want to whoever is going to take the screen will implement all the way up to the node class, but not the stack class. Okay, and then I'm just going to turn the laptop around, give it to you. And someone is going to, hopefully not Richard, Brandon, the people who usually call out the code, Mark, right? Someone who hasn't, first of all, so I want to pick someone who hasn't coded so far. Francis coded last time. Someone said they wanted to code this time. Hey, ASOS, you said you wanted to code again, right? Did you say that? Or, because Isaac just coded.
Yeah, I could if no one else.
I could code if you don't want to.
Sophia, yeah, all right, yeah. Actually, Sophia, you should code, right? Because you were absent last time too.
Yeah.
Yeah, all right, okay. So Sophia is going to code, and hopefully all of you guys should actually call out the code. and say, get everything implemented up to, you don't have the stacked class, okay? So everything up to that, and then I will join you guys, okay? Does that sound like a plan? Everybody? Okay, all right, great. Thank you very much. Okay, so I'm just going to be here. So if you need me, you can just, call my name. Otherwise, I hope to hear the airwaves occupied all the time. Someone should be talking, okay? Yeah, or Sophia should call Ed and say, hey guys, tell me what I should type here.
Yeah. Sorry, is there a link that I'm missing?
Oh, you have to share your screen, by the way, Sophia. You have to share your screen and go to onlinegdb.com.
Okay, let me open up a new tab.
Incognito window, okay? Open up a private window and share your private window, and then go to onlinegdb.com, and then delete everything, and then you're going to implement the node class. Now I don't want to talk you through the comments at the top and all.
Okay, the node class.
Yeah, delete everything. Command A or Control A, and then delete.
Mm.
Are you guys?
And yeah, let me know if any of you have any input. So, it's like the value and the pointer. What's it called?
Why is nobody else talking? Is it only so?
Didn't any of you do the homework?
I guess we want to include
no, it's
IO
string.
string before that.
Include, what was it?
IO string.
Yeah.
Include IO string. I just don't want to talk because like professor said like we should give the chance. No one's really picking up.
Be right back. I'm just gonna get a charger for my computer. Oh, right. Okay.
Hey, what's going on, guys?
You guys remember the name of the variable for the pointer?
Someone should be talking all the time.
I
believe it was called next.
Okay, next. And there's like a constructor, right?
If it's going to be a pointer variable, we need an asterisk before next.
Yeah.
You can put it, or I don't know if it's somebody else can give their input on this. I don't know if you're supposed to put it with next. That's what I would do. like connected
Oh.
to next instead of int, but sometimes I don't know. I read it as like preference, but I don't know.
I just want to pull up my homework so bad. Yeah, I don't remember where the asterisk goes.
No, so I think next was a node, right?
Yes, it was a node. Yeah.
Yeah. So it should be of type node instead of int. And we did an int for the data, I'm pretty sure. So instead of string val, it would be int val, and then node next.
Okay.
Also, before we continue, you can either put using namespace std towards the front, or we can do like std : before we do something like int or string.
Yeah, I think you should add. Oh no.
Oh no,
No.
hashtag.
Yeah,
Okay.
just the words.
I remember this constructor was written in a way that I didn't really see before. I was wondering if anyone remembered.
Yeah, so maybe you can go, so those are private. I think you have to have private before the variables. Like above line 4.
Sorry, I'm just turning the volume up a bit. What's that?
I think those were under private. Those are private variables in the class, so under line
Okay.
3. Just put private with a colon.
So it had private, but it was a struct, which would mean everything is public. I
Right,
don't
right.
know. Yeah, I don't know if we can just do it. I think we might be able to just do like struct node and not put private or public. I don't know. Somebody else has to confirm.
I think last time we did class node, and then we have like class after that.
Yeah, I
Yeah.
think the
And
struct
on homework
was in
it
the
was-
homework.
On the homework, it was struct. Was it
Right.
private
Yeah.
or something?
Yeah. I don't know if you're doing the one from the homework or the one from like last class.
How does the syntax look? I kind of don't remember.
So struct was used, but it wasn't used within the node class. It was under, was it a stack or a linked list in the homework? So it's either we create a struct for a node or we do just a class. I think for simplicity, we should just do the
I'm so
class for
sorry.
both.
I can't hear you very well. I'm gonna try to like.
No, maybe it's my mic. It could be me. Check.
We can let's just get rid of struct and then we can just do like private and public. Just go ahead
Alright.
and do that.
Oh, by the way, I'm just asking, what's the goal of this? Are we trying to get a linked list?
That's a good question.
I think we're trying to set up just the node itself to lead up into something that the professor wants us to do afterwards.
Yeah.
Let's put a public before like node, the constructor.
Okay.
Is it done?
There's a way to write this. Wait.
Oh.
Something like that.
We don't need the node start in, I think. It would just be one node where initializing. Right.
I don't need this node. Sorry.
Yeah, I think we're just the constructor just creates the first node.
Okay.
So you just take in the data.
So just, yeah, just the data that's coming in, and then we initialize next the null pointer.
Okay. I'm not sure where to initialize it.
You can put in like
I wrote
int
something in
v.
the chat,
Oh,
but yeah, go for it.
And since you're doing int val instead of data, we can do like v, int v instead of int d.
Cool.
So like our name was Val, right?
Name.
Yeah, like should we change int val to int data? So you have like data v. Because right now I have two variables. Like
Oh.
that was
Oh, yeah. It should either be int v data v or int data with int d and data d. Sorry if that's confusing.
No, so data and val should be the same also. So it should be val value data data.
Okay.
So I think we had a get data method. I think it was int get underscore data. Get underscore data. Yeah.
But yeah, were there like underscores here?
Yeah, we could do that.
Make sure to put the underscore in front of next
Oh.
in line 9.
Yeah. Okay.
And then we had get next, but this one, since we're not returning a integer value, this one is node. And then it's node pointer, and then get next. And it's the same structure.
Cool.
And both of these were const. So you have to put a const after the parentheses.
Sorry, I forgot what that means.
No, like constant, const. We have to put that after the parentheses. Or after the open, yeah.
Remind me what that does.
It's like a sort of, I like to think about it as like a promise that it's not going to modify the original value of like, well, for data it would be data, and for pointer it would be the
Okay.
pointer.
Okay, yeah. Cool.
Okay. I'm gonna take a look, just in case you guys don't go down the wrong path and end up implementing a lot of stuff that we don't actually need. All right, let's take a look from the top. So you didn't put any comments at the top saying class code for, I think it's good, a good practice at the top, just in case people come across the online GDB link, they don't have to scrub the video to look at the code. They can actually, just put class code for today's date, June 18. We want to implement the node class from before. Again, it shouldn't take you more than 5 minutes to knock out the node class, okay? The reason it's taking you this long is because you guys didn't have practice, okay? Because maybe eventually you come up with the correct structure for a node in 30 minutes, okay? That's not enough. It's not enough to cut it as a programmer. It may be enough to squeak through some kind of exam or test that says, yeah, okay, I know what this thing is at a conceptual level. But in order to cut it as a programmer, this kind of thing should take you no less than, I don't know, 1 minute or something. And it's not like it's magical and these things are, people just have the, magical ability to do that. It's just, you have to do it 4 or 5 times, consciously, mindfully, instead of, thinking about something else. Just do this. And after that, you'll just find it's coming through, just flowing through, right? So when I said, we'll do the node class and take that to implement the string class, list class and so on. All right, 5 minutes for node, and you should all be done. You should not be searching, right? After you start, you shouldn't be searching for, all right, is this the right, is this jiggling things around just to make sure it looks right. That only happens when you don't have enough practice, okay? And by the way, I can't stress enough how much practice is going to help you save time in the final exam. Obviously, you can cheat and you can have stuff, and you can take a photo even with your phone with ChatGPT and say, what's the answer? And it'll tell you the answer too. So all of that is possible. But if you want to do a, sincere job at the final to figure out exactly how much you know, then I think that these mechanical handicaps should not get in your way. That's what it is, okay? All right, so if you want to use any test to figure out how much your mental skill level is, you should try and get as much of the mechanical handicaps out of the way as possible, because they all just corrupt the final reading. You want to just figure out how fast you can think to solve that problem. And in order to do that, you just need to get all the automatic stuff taken care of, made truly automatic. So you don't need mental cycles. You don't need mental cycle to format things a certain way. Many of these things can just be autopiloted. But if we don't autopilot them by practice, they'll just take up a lot of your cycles. And so you won't have 100% of your cycles devoted to the actual problem at hand. That is actually, I think, what happens most of the time. So I would say that all of you as a class, even though you are, in computer science and attending in the last week and all, you're still lacking practice. And you have to practice again and again, even if it's the same code, write it one more time. Without looking at the previous code, write it one more time. And then did I do the exact same thing, or maybe I changed one thing around to make it faster? You never know, right? You do it again and again until it just becomes natural. You have to do that for the final. Otherwise, you'll just end up wasting a lot of time just figuring out what's going on. Oh, is that going to be I-1 or I+1, right? But that's the kind of error that you should run into a million times as you're coding, so that kind of confusion doesn't happen in the final exam at the last minute. Because all right, okay, this place I just watch out for that corner case where I is either less than or equal to or less than. Okay, because you've encountered that many times. All right, let's get on with this now. Is this the max now? Can we go from here? Yeah, okay. All right, so everybody needs more practice. Okay, so after this is done today, I would like what is today's Tuesday? Okay, all right, Thursday, this is my plan. Okay, Thursday, we will do the node class and the list class, and then we will do a main, which is going to hopefully be a game, okay, that leverages the list class. Hopefully, all right, Thursday is the last lecture. Okay, all right, let's see, that's the plan. Okay, my plan is for Thursday, we'll do a game based on the list class. Now, today, what we'll do is develop the list class and all the methods that go with the list class, and some interesting things with it. That's all we'll do. That is my plan. So I will talk you through the code, and maybe in the code, I will leave spaces, say put comments saying to do, fill this in, and you'll get some time to fill it in. But you shouldn't take like 15-20 minutes and discussing left and right, and don't waste time talking about should I move commas and things like that. So get it done as quickly as possible, and then we can shuffle it around and make it look nice. We can take our own sweet time with that, okay? So I'll put some to-do items in the code that you should be able to finish. And after we are done, I would say that before Thursday, every one of you should implement this from scratch to the end, from the beginning to the end, without looking at the previous code, just knowing what you have to do, right? Maybe the first time you have to look at it one or two times, right? But at the end, you should get to a place where you can do it from beginning to end without looking at it, okay? You know what you have to get done, and you just knock it out. And when you do that one or two times, that's basically it, you're set, okay? And then it'll just help you in the next program too. Even if though it may be different, it'll be, lots of students don't do that. I think that is the biggest challenge I find. You just have to bite the bullet. Bite the bullet, as I think that's the English expression. Bite the bullet and say, well, you know what, my Sunday is going to be screwed because that's all I'm going to be doing all day. All right, so just knowingly sacrifice the whole of Sunday. All right, from 7 a.m. until 7 p.m. saying, other than bio breaks, I'm just going to be doing this program from beginning to end, and I'm going to keep a count, right? Counter program, like on your phone, you have these counter programs. You can say, oh, all right, I'm just going to keep a counter program. Hit that. I need to get 5,000 times. I need to do that, and so on and so forth. You have to say 5,000, right? You set a target like 10 or 20 or something like that, and say, I'm going to do that. And that's all I'm going to do all of Sunday. And you'll find that it'll actually, if you pick this task with the linked lists, I would say that just devoting all of Sunday doing this from beginning to end all the classes, many times will prepare you a great deal for the final. Okay, because it'll involve lots of skills, for loops and conditions, looping in different ways, looping with I equals. And the other thing that I don't know, Mark or someone made a note, Ethan maybe, that hey, first time I looped with a list linked next variable, right? I someone posted a link, very interesting. I don't know who it was. So we'll do two kinds of loops and loops over pointers. All of these skills will be covered in this. So if you do this from beginning to end, one whole day, that will save you a great deal of time and effort during your final, which you can devote to other, more demanding classes, right? And that's right. So how about this? Now, so I'll just continue to call out the code, and at some point I'm going to say Sophia should hand over to, not now, okay, Sophia?
Okay.
So at some point I'm going to say, am I looking at everybody here? All right, Jesus, you wanted one more chance to code too, right? Before the end of class?
Yeah.
All right, at some point today, I think, well, Sophia will hand over to you and then you can take over. Is that okay?
Yeah, of course.
Okay, all right, okay, great. So let's go to line number 20 and hit enter. All right, so you got the, I see, you got the constructor, and okay, that's great. And the getter, you just need setters, right? So you need setters for all of them. And the easiest way to just copy for lines 14 and 14 all the way to 20, paste them all over again, and change all the get to set, and change the signatures and everything accordingly, and you'll just get it done really, really quickly. Okay, change all the get to a set, and then change all the return types to void. No, actually, you can say, what is it? List. Oh, this is a node, is it? Yeah. Why don't we make it simpler? Since we've done this already, I'm just going to make it. Well, you do need practice, but for practice, do this stack class, and we'll make this simpler by making node instead of writing setters and getters. It's really a pain. It's a mess, isn't it? Okay, and it bloats up your code and all. Just make, instead of class, make it struct. Okay, instead of class node, make it struct node. Okay. Okay, doesn't have private. Everything is public. Okay, just get rid of private. Yeah, get rid of that. And then get rid of the blank line too. No, we need those two variables. No, not the word. We don't need the two. Yeah, that's right. We don't need the. Oh, I see. That's why it was more fatter, because you had double intent in some places. I see. Okay, no public item. Everything is public by default. Okay. So now, we need the constructor. Let's have the constructor. And then we don't need any getters or setters.
Okay.
Yeah, just have the constructor. Next line. Yeah, get rid of all of that, and then put.
That's what we
don't need any getters or setters. However, that's basically it, right? Get rid of the blank lines. Get rid of all the blank lines, and put a semicolon at the end. Hey, this is really cool, isn't it? I actually didn't expect it'll say, we whittled down so much that it'll just be like this. Get all the blank lines, and also one blank line above, the constructor. Line 10 can go. Well, you need one blank line there because it's, what happened there? It says node. Yeah, there you go. Tab now, tab in. What's going on?
I think maybe I have an insert, yeah.
This is a Windows machine? All right,
Yeah.
now next line, next, put a blank line above that so that the constructor is separate from the members, and then unindent the closing brace and put a semicolon at the end. Okay, that's our, now a struct is essentially just the same as a class in which everything is public. I think someone asked a question even last class. So this is actually instructive to try and use struct just to see what it is, why it is exactly the same as a class in which everything is public. Okay, this does mean you don't no, you don't need a blank line there. That's it. All right, now let's go to a semicolon at the end, of line 15. That is basically our class called node, in which everything is public. So everybody can access node and data and next. Semicolon at the end of line 11. Yeah, enter. All right, now I say, what did we want to do? Yeah, we want to do a list. Okay, all right,
List class.
yeah, okay, so you can say class list, space curly brace, enter. And inside, let's just have a head node, okay? Say node star head. Node space star head, yeah, thank you. Yeah. One sec, okay? Okay, hey, you know, I think this is, because this is a class and we're just going to do an interesting experiment here. But let's put a comment on top, go to line 12, hit enter. Go to line 12, hit enter. And by the way, list should be capital L. And also, yeah, but also because little L is the name of the STL class, you know, but doesn't matter because we're not including the STL include file. Okay. All right. So there you're going to say this is a singly linked list. This is a singly linked list which does not know its own tail. Does not know. It does not track its own tail. That does not singly linked list, not lit, track its own tail, right? Meaning that you'll have a node which points to another node, points to another node, and so on and so forth. But you don't know which one the last node is unless you start at head and keep on going until you hit some node which points to null. Okay. So a list is basically a chain of nodes in which the one of those nodes points to a null. And it is a list because each node can only point to one node. So you can only get a chain. You can't have a graph or a tree where each node points to more than one node. Yeah. And a node can be null because it's a pointer. It can be null. Yeah. Because if it's not a pointer, it can be null. You have to have a sentinel. Because if it's not a pointer, it's some memory. You have to have some way of distinguishing it from something that's invalid. Because a pointer, just like in Java, you can say it is null. Null means that it doesn't exist, right? It takes an extra bit in other languages, right? But that's basically what it is. So here, all we're going to do is our list is basically just a pointer that says this is the head of the node. All right. So now hit and make that private now, right? Private, and then line up private with the word class, right? So that you don't waste an extra indent level, right? So yeah, colon. Okay, and then we need public methods also, right? Yeah, enter, one more enter, and then public. And for the public methods, we need the constructor. You say capital list. So you say list my list, and then it'll just give you a list with an head pointer that is pointing to null. Okay. Okay. All right. Okay. All right. No list, and then no parameters in there, right? Yeah, you're just going to say list. The default, but we're going to override the default constructor and say this is what it's going to do, right? So now put a semicolon there. We'll do it out of line. Okay, we'll do it out of line. We'll do it as a semicolon. We'll define it outside. We'll define semicolon, and then what else? We want to say list push front. Okay, let's push front. Okay, and then that is going to take let's say int d, right? Int d. No, int d. Push front. No, push front is going to take an int d.
Okay.
Yeah, int d. And then it doesn't take and it should return not a list. It shouldn't return a list. Should it return a list? One sec. Okay, just give me one sec. I'm thinking. I think let's make it return the list. Okay. All right. Yeah. Say a list star. Let's make it. And you can actually question these in the forums and say, hey, why are we returning the list? Why are we doing this? You know, and these are there advantages or disadvantages? Let's talk about these things. Interesting things to talk about in the forums. So list star, and then also the first parameter, right? A list star push front. The first parameter to that should be list star this list, right? List star. Yeah. No, wait one sec, okay? So you're going to call it on a list, and then it's going to do something and then return that list. Oh yeah, all right. I'm so sorry. Okay, so yeah, you don't need the first parameter. You're just going to call it on this. It's going to get past this. All right, push front. Is that it? All right. We need one more method. Yeah, this is the one we need the other parameter for. Let's just do the push front now. Okay, and then we'll do one more method. We'll say show print. Print list. Okay, we'll do a print list, void print list, and then we'll do one more. Okay, one more, void show animated list. Okay, show animated list, and both of those should be const methods. Yeah, animated list. Okay, open close.
How we implement that?
Yeah, it's gonna be fun. It's gonna be fun. Okay.
Yeah.
Yeah. All right. And we're gonna use a /r character and sleep. Okay. In a clever way. Maybe we don't even get to it by the end of class, but you'll have you guys have a fun if a lot of fun figuring it out. You have to use /r and sleep to good effect. So the idea I have in mind is that you're going to show the whole list. And so 1 arrow, 2 arrow, 3 arrow, 4 arrow, and so on, and then last one arrow null. Okay, sleep 0.2 seconds, and then you're going to shift the whole thing, 2 arrow, 3 arrow, 4 arrow, one's gone out. Okay, and then you're going to show it on the same line with spaces on the end with a /r, so that it'll look like that entire list has shifted to the left. Okay, and you do that in a for loop, 0.2 seconds after each, it'll look like that entire list is shifting out. Okay, and when it hits the end, you can say that's the end of the list. Okay, and I think I'd like to see that animation because I want to use that in the game next week. Okay, so we'll try and build a game out of this animation that we built. And if we don't get to it today and by the end of class, you guys should totally try it, right? And say, hey, here's my version of the animated show, showing a list. And I had a crack at it, and you can share this in the forums. Okay, all right, make that a const. Okay, a void print list should be const, and then show animated list should also be const. Yeah, the previous one also should be const. Okay. Should we do void print list, or I'm thinking we could actually overload the operator. Instead of void print list, say string to string. Okay, I think that's much better. String. Say instead of void print list, say string to string. And that is more conventional. And everybody will know what the hell it means. Yeah, and then const again, const. Yeah, all right, okay, great. And get rid of the blank line on line 23, yeah, and semicolon at the end, and then let's start implementing those guys. All right, let's do the constructor first. Okay, so I say list ;: list. No, list ;: name of the class. List ;: uppercase list, no space before that. Yeah, all right, open close. Yeah, space curly brace. All right, so in there, what we're going to do is, we actually do need a destructor also. That is so cool. All right, okay. All right, great. I forgot about that. Okay. Yeah, let's, so here we're going to say, I see, node star head node equals, node star head node equals, new node, node star head node. Yeah, head node equals new node. And then, and you can say -1. No, actually you should say npos, okay? String ;: npos. Oh, I see, it's an integer. Oh, wow. If it's an integer, instead of int data, make that unsigned data. We'll just say they're all going to be positive numbers, okay? All right, we will just assume that everything is going to be positive, and then if we have negative, it's in legal value. I think that's fine. We'll just use int all the way through. Yeah. All right.
Okay.
So now, however, when you call it, the new node with a -1. All right. Okay. Semicolon at the end. Now let's put a comment at the top of this function because it's very, it's doing something that's unconventional. Maybe could be seen as unconventional, and that's usually the time when we have to pop a comment in just to make sure that people are on the same page. All right. So this function will allocate a new head node for the current list. On the heap, right? On the heap. The value of the data item in the new head node is -1.
Wait, sorry.
Oh, I see. New head node for the current list. Right, on the next line, you can say the value of the data item in this head node is -1. On the next line, you can say, note that regular nodes will only have non-negative data items, meaning, right? By convention, meaning we're sacrificing all the negative numbers as sentinels that you can use for various signals. They're all invalid, actually, as numbers that, so yeah. All right, okay. Okay.
Good.
All right. Yeah. It's a very inefficient use because you can't see. Again, it is it is a source of a C++ programmer's discomfort, meaning that you have to return. You say, I don't know. Maybe you can think about this and discuss it in the forums and say, what is the source of this discomfort? But for a programmer who's used to programming with bits and bytes and making use of all the available things in the most efficient way possible, we know that we have to have integers, but we also want to have a sentinel, one value that is not an integer. How can you do that, right? You should say, well, you know what, this particular value I have to reserve. But here we're doing a very inefficient choice. We're saying, even though I just need one illegal value, I'm going to assume all negative values are illegal. That's essentially what we're doing, right? We're just saying we want a list of only positive integers. And so think about it in other languages, in any other languages which don't make a distinction between positive and negative integers, right? Anytime you have an array or a vector of quantities of that substance, you're essentially just wasting one bit, right? What happens in Python if you have to process an enormous array of temperatures of astronomical objects in Kelvin, right? Yeah, you can never have negative Kelvin, right? So Kelvin is non-negative. So you can have enormous files of huge numbers of values, and they're all positive. Even neural network weights, they're all positive, or non-negative, I think. Well, actually, they could be negative, I guess. Right. Okay. So, but I'm saying some things can't be negative. But if you're constrained to programming in a language which says I have to waste a bit, then you say, well, you know what, I can't afford to waste a bit here just for the sake of using this language.
Professor, I have a quick question. In line 29, where it says like new _ node, is that like,
oh, new space node?
It should be new space
uppercase node. New space uppercase node. I'm
okay,
so sorry.
right.
Is that what you meant?
Yeah, I just got confused because it wasn't like declared beforehand.
Yes. Now it looks good. Yes.
Yes.
Thank you. Thank you, Eugene. Well, at least I know that one person is paying attention in class. All right. Okay. Node. All right. Now, you know what? We don't even have to call it. We have a variable called head in our. Yeah. You just say head equals new node, right? We don't have to say node star head node. We can say head equals that instead of node star. No, the previous line where you said node star head node, you just say head equals because you already have that in there. You have a variable called head, which is node star. And you don't need node star. You just say head equals.
Okay.
Because head is
yeah.
Okay, I get rid of the next line, blank line. That's basically it. I think that is a constructor. Okay. Now on the next line, you have push front. Okay, so oh, we need a destructor too. So yeah, you go to line 19. Go to line 19. Hit enter. And this is the first time you're implementing a destructor. All right, so I think it may be useful to, yeah, and you need a tilde sign in front of the list. That means it's a destructor. This code will be called every time a list is destroyed. Okay, tilde sign, right? And at the end, curly brace, semicolon. Yeah, like that. What you had there, a semicolon. No, you don't know. We need the body outside. So just we're going to define the body outside. Curly brace. No, get rid of the curly braces. I said curly brace. I remember saying curly brace. Sorry. I meant open close parentheses. Okay. All right. Okay. Now you can put a blank line after the constructor destructor pair, and then the other three, kind of regular methods. Okay. All right. Now let's do the destructor. Okay. Let's do the destructor. So go to the line. Go to line 32. Hit enter. And then say list double colon. This autocomplete is really painful. It's just getting in the, it's covering of the code. There should be some way to turn this off in online GDB. All right, list double colon tilde list. Open close. And then space. Yeah, there you go. Right now, here's what we're going to do. What we're essentially put a comment there, saying we are going to. Yeah, you can do that too. You can put it there too. All right. We are going to peel off one node at a time from head and release it until no more nodes need to be released back into the heap. Okay, that's all. Now, I'm happy to talk you through this code, or you guys, it's only 2 lines, but it is looping in a different way. It's not using I equals looping, right? It's going to loop in, saying node equals not null. So it's a different kind of looping. If you guys want to do it, you can do it, or I'll do it this time. And maybe, on Thursday, you're going to have to do it yourself.
Sorry, what was the last part of the comment?
We're going to peel off the peel 2 Fs, peel off one node at a time from head, and it's is it not underscore head? Okay, what's this head? Okay, and release it until there are no more nodes left to peel. Yeah. Okay, so so the code for this is actually very simple. Instead of using a for loop, let's just use a while loop. Okay, so what we want to do is while head. What is it? Yeah, well, yeah, while head is not equal to null. While head is not equal to null pointer. Yeah, and you don't need curly braces either. Oh, maybe, yeah, you need curly braces. You need 2 lines. Okay, so curly braces, and in there you're going to say node to free equals head. Node, no, one word is I say node star node to free equals head, node star node to free, node star, or no, even node star temp. I think that's what Mark used. Okay, now node star temp equals head. Yeah. All right, semicolon. Now you're going to say head equals head arrow next. Yeah, and then next line is delete temp. Okay, this is another kind of looping, which doesn't use incremental arithmetic looping. It is a yeah. I think this is what Mark did, and I think he made a post saying I changed things around so it saved 1 line. So maybe this is what he did. I forget. But it's interesting to look at different versions of the code and say, what's the plus of this and what's the so you should compare and contrast all the time, like he did, right? Sometimes it's just a lexical difference, and maybe sometimes a lexical difference makes a difference. Maybe it's easier to read or harder to read, but sometimes it is an efficiency change, right? It changes one less iteration through the loop that matters. So all of these things you tend to notice, and you actually start appreciating about the code. Actually, you'll be starting to appreciate the mind or the thinking of the programmer who wrote the code, because when you're looking at the code, you're thinking about certain corner conditions that you could only encounter if you were the coder, because you're actually running the code in your head too. And when you actually see that, oh, this has been accounted for, that means the person actually, so you actually commune with programmers who may not even be alive. And so that's like communing with an artist when you relate to a piece, yeah, like that, I think. All right, okay. So this is.
Do we need a do we need a parentheses for temp and delete temp?
Actually, we don't need parentheses, but I think parentheses don't matter. But let's get rid of the parentheses, okay? Because just like new, delete.
Oh, so even with the parentheses, it would still like compile?
I think so, because temp within parentheses is just an expression. Oh, expression, but it will evaluate to. No, it should still evaluate to temp, not an immediate variable. Actually, I'm very curious to find out. Jim, you should do an experiment and find out, right? And you should post about it.
Yeah, sure.
Even new. So new and this. No, new always takes a, All right, okay. Is that it? Okay, so we got, oh, I see, we need to implement a push front. Let's do push front. Right, string push front. No, dude, that's done. We're done.
Okay. Oh, and okay.
Yeah, so let's do push front. And then maybe, Jesus can do the one after that, right? The two string and the other one, maybe Jesus can do those two, right? Push front. And then what does it take? It takes an integer as a parameter. Integer D. Okay. All right. Now this is something you can do here. And what does it return? Does it return? It returns a list star, right?
Yeah.
Push front returns a list star. So return list star. So return list star. On line 43, on line 43, at the beginning, the return type of that function is list star. Yeah, so you can go to the beginning of the line and say list star. Beginning of that line. No, not there. At the beginning of the line.
Okay.
Yeah, there. Okay, and say list, a space star. Same as what you have in the declaration. Yeah, I put the star on this side of the space because it'll match what you have in the declaration also. All right. Okay. All right. Now, and then one of the things that we can do is actually enforce that if you're actually push fronting an item into the list, it has got to be greater than 0. So you can say if D is less than 0, return null pointer. Yeah. Okay. All right. That means that, so you can put a comment on the top of this function if you want that says pushes a non-negative integer onto the head of the list, returns null pointer if the number is negative, right? Otherwise returns the list itself. Next line, actually, it's getting too long.
I'll change it.
Yeah. Okay. All right. Okay. Now let's go to line 48 and hit enter. And you don't need braces for the if because it's just a really, instant quick thing. So you can get rid of that. You can save a line. All right. Okay. So let's go to 40. Yeah, there you go. 49. So here we're going to create a brand new node. So you say node temp equals node star temp. temp equals new node. And within parentheses, you're going to say in D. Now you know it's either 0 or greater, yeah? D. Semicolon. All right, now this has got to become the new head, right? And head has got to be, this guy's next, yes or no? Yeah? So you can basically say temp arrow next equals head. Yeah. Semicolon, and then head equals temp. Hey, really nice triplet of lines, okay? And it takes a while because it just looks like circular assignment, and one is, you know, what the hell is going on? And then it takes I don't know, a little while of just imagining this thing, because you know, A equals B and B equals A. Does it work? Interestingly, you know, if you want to do a swap of two variables without using a temp, that's something you can do. You know, you want to swap A and B, and they're both integers. You can actually just do it with arithmetic operations without using temp variable. I can show you how to do that later. But anyway, this I hope I got it right anyway. So you're creating a new node, okay, and you're taking the head and putting it on the next of this guy, and you're saying head is now this guy now. That's all, okay? So we inserted the new node. All right, that's all. Do we have anything more before the two show the print methods? You know, otherwise, Jesus can. I think this is it. Yeah, so far. But we can't write a main and test it yet, you know, until we have the show methods. So we'll do that with Jesus. And then I think we'll be ready to actually do main. By the way, on Thursday, you guys should just be ready to code this whole thing. How many lines is this? 50 lines, right? Or maybe with the two show methods, it'll be like, say, 60 lines, okay? 5 lines each. That's including comments and all. You should be able to code it in 10 or 15 minutes at most, okay? Meaning if you're taking longer, it doesn't mean that it's harder. It just means that you haven't practiced enough. That's all, right? Even people who just seem to get it naturally, they've just been doing it. Whether they know it or not, they just, you know, even mentally simulating it and saying, I'm just going to keep coding a certain number of times, and you just get faster and automatic. So it just means you have to invest time. So just take it, you know, your prof says that's what you got to do to get an A in this class. You just have to spend the whole day and do it. Okay. All right.
Make sure to add the underscore in front of next.
Do we have a?
I think we added an underscore. I don't know if you changed it or.
Oh, we
yeah,
did.
okay.
We did. Yeah, we did. Yeah. So and then data also. We're not changing data? No, we're not changing data. So we need underscore next. Yes. No, in the function that you just wrote, temp arrow underscore next equals.
Great.
Yeah. In fact, to be consistent, even for our list class, the head should have underscore head. But you know, this is online, not VS Code. If it was VS Code, you can just do refactoring and it'll rename all over the place.
Yeah.
Let's not risk it. Okay. All right. I think this is good. Let's pick this code apart for a few minutes, maybe a couple of minutes, and then Jesus can take over, and then we'll code the last two methods that I had in mind. Was this useful, Sophia? Yeah, it does look like you need a bit more practice too. Yeah, everybody needs a bit more practice, especially if you were absent. You were absent the last couple of classes. Yeah.
Yeah.
So you got to make sure, all of you, just keep coding. You know, take one day off. And thank you very much, Sophia. All right. How about share that orange URL, and then Jesus can pick it up and fork the code, and then we'll just take it from there and code it. Okay. First one is print, yeah. So we'll just start there and say number, arrow, number, arrow, number, arrow, and then null pointer at the end. Okay. And the other one is show. All right. And that's the one there where we have to do the, yeah, we got time for this. 722. We're talking about like, I don't know, max of 8 or 9 lines of code more. Okay. That's all. Not a great deal more code. Totally, if you guys want to do it too, I'm more than happy to, especially when it comes to the animation and the main part that, you know, in main we're going to show, and maybe we'll do it. Okay. Yeah. Together. Hey, whenever you're ready, Sophia, have you shared it in your chat window?
Yes.
Jesus, have you picked it up or not?
Yeah, yeah, she just has to stop sharing her screen real quick.
Okay.
There we go.
Great. Fork the code so that you can, oh, it's already forked?
Yeah.
Okay. All right, list. All right, so what are the last two ones that we want to do? Two-string. Oh, let's do the two-string, it's easier. No, this is done. This function is done. So let's go to the next method. If there's a blank line, you got to get rid of the blank line. Oh, and also it has to return something, yes? Return this, return blank, enter, hit enter,
Yeah.
and say return this, semicolon. Okay, everything in this code is subject to, points in, the last week participation. Everything in here, I'm not putting comments in code saying, well, I used to do that in the previous classes where I say, oh, make a comment there. Interesting. Why did we do this? Discuss in the forum. And I'm doing 4 or 5 of those, and only a couple of people are picking up on, and just not all of them too. So I'm not going to do that. But however, all the code we're writing, there's so much scope for just picking out things in 2 lines, 3 lines. Say, why did we do it this way? This seems better. Or maybe I got another idea. All of those things, prime opportunities for you to discuss in the forums. Okay, we're just not annotating that anymore. Like return this. Why are we returning this? Okay, all right, so go to line 54, hit enter. All right, and yeah, one more enter. And then say string to string. Okay, string to string. No, string. It has to return a string. No, yes, string. Space to string. And then list double colon to string, by the way. It's a method, isn't it? List double colon to string. No, uppercase list. As 2 colons. You got 2 colons there or just 1? You got 2 colons there. I can't actually see. Hang on. Oh, you got 2 spaces there. I can't see colons at all. List after the word list, you need 2 colons.
Oh, sorry.
All right, okay. And get rid of the space after that. Okay, all right, okay, great. So now, so what this is going to return is, all right, let's say we're going to do it this particular way, but you can do it in any way you want, okay? Let's say string stream SS, okay? String stream SS. Actually, I think it's called iString stream SS, iString stream SS. iString stream ISS, right? iString stream, one word. No, iString stream. No, you don't have the word string. iString stream.
Oh.
Get rid of the word string. Get rid of the word string.
Oh, sorry.
Okay. iString stream.
Oh, stream.
No, iString stream. iString stream. Stream. ST. No underscore. Just string. Okay, yeah. All right, space. In fact, it's not iString stream, but that's okay. Say OSS, semicolon. Right, and change the iString stream to OString stream. It's not an input string stream, it's an output string stream, right? All right, now hit enter at the end. Now here's what we're going to do. One more enter. And say for let's say this, okay? For node star P equals head arrow next. For node star P equals for node star P equals head arrow next. Okay, head arrow next. No, not arrow. Head and then arrow is hyphen and then greater than. No, hyphen and then greater than. Okay, but so these are things that you got to practice a lot, everybody. Okay, so arrow and dot, you should just like be like that. Okay, because there's going to be at least, I don't know, maybe at least 10 or 15 points in the final that take advantage of these things. You got to know these things. All right, head, yeah, head arrow next. No, hang on. How do we? Oh, I see. Yeah, we're inside of the. For the list, how do we get the? Oh, underscore next. I'm sorry. Underscore next. Thank you. Yeah. All right. Semicolon. Yeah. Can you hit control plus one more time, please, if you don't mind? Yeah. Just hit control plus, command plus, or control plus. All right. One more time, actually, please. Yeah, I think that's much better. Thank you so much.
Should node be capitalized? I don't know.
Yes. Thank you, Richard. Okay, node star, and then put the P star attach the star to the P. All right, node star P equals head arrow next, semicolon at the end of, not there. After next, you got a semicolon. This is the other, yet another kind of looping that we need to know. No, after next, after the word next, yep, semicolon. Yes, space. No, don't put a curly brace. No, don't put the parentheses there. Yeah, inside. Yeah, space. All right, and say P is not equal to null pointer. P is not equal to null pointer. Yeah, semicolon. Space. P equals P arrow underscore next.
Can you repeat that? Sorry.
P equals P arrow. P equals P arrow. P arrow. Arrow. Yeah, underscore next. And no space before the underscore. Get rid of the space before the underscore. Okay. All right, now curly brace at the end. Great, thank you. All right, now you're
also,
what about
sorry.
the head? The head, there's a space there.
Yeah, you got a space there too. Get rid of it. Thank you, Richard.
It should also be a const, because that's what we declared it as.
Oh, I'm sorry, what should be a const? Oh yeah, two should be a const.
String.
Yeah, so on line 56 at the end of the, just before the curly brace, say const. No, at the end, just before the curly brace. Just no. Just go to the, no, don't do anything. Go to the end. Right. Curly, now say const. Because if you did something, then it'll take more time to undo it and then go here. Yeah, that's why I said. All right, okay. Now 60. Here, all we're going to do is print the data item in P, right? And then the arrow sign. Okay, so you're going to say OSS, yeah, left shift, space, left shift, space, left shift. Yeah, left shift, 2 less than signs.
Oh, sorry.
Yeah, that's okay. Left two less than signs, 2 less than signs. No, not greater than, less than. Yeah. And then you're going to say P arrow underscore data. Yeah. And then after that, you're going to say, yeah, and left shift again. And then you're going to say, within double quotes, you're going to say, arrow or something like that, right? You can say, yeah, let's say arrow. It's cleaner. Okay, or just say half. Just say dash, right? So it's going to print all the numbers with a dash in between, and then yeah, right, put a dash, yeah, and no space. Okay, and then semicolon at the end. Yeah, and now outside of the for loop, Oh, we only have one line in the for loop. So you can get rid of the braces also. So you don't need braces for the for loop because you only have one. We'll save a line there. And the previous one also, the opening brace. The opening brace also. You have to remember, because otherwise you can save time on the compiler error. Okay, yeah. All right, and enter. All right, now you're going to say, oh, I see, you had it in the right place. Sorry, go up again. Yeah, I'm sorry. Yeah. Right. So you say OSS, left shift. And then the word null in uppercase and within quotes. And make it all uppercase so that it's, stands out. Yeah. And then you can say left shift also an end-L at the end. Right, say end-L, a semicolon, enter, one more enter. Yeah, and now return OSS.str. I think that works, okay? Otherwise, we'll find out and we'll have to adapt it. So what we're doing is that we're building up the string in an output buffer. It's an output stream. So we said output, and in order to use that, you have to go all the way to the top of this file. And where you have a hash include IO stream on the next line, you also say hash include S stream. Okay, so go right to the top of the file.
I think, don't we need
Right to the top.
Oh, sorry.
Right to the top under IO stream. Yeah, hit enter under IO stream. Hash include S stream for string stream. No, I think there's something, left angle bracket. Yeah. S stream. What's going on? Is this the autocomplete getting in your way? No. Why is it all uppercase and everything? I can't even see these things, and so I have to look so hard. No, it's the two S's. I'm sorry. Okay. Yeah. And blank line after that. Okay. Online GDB is starting to be a pain. We got to find some other, maybe next quarter I'll find something else. So the autocomplete already when Sophia is it's obscuring part of the code, and we can't tell what the hell is going on. Especially, with me, my wrong glasses and, half the screen. It's very hard for me. All right, okay. I didn't know, that's okay. Now we can go back to the end of the code. That's basically it for the two strings.
I think, do we need empty parentheses at the end of str?
Where is it, sorry?
OSS.str. 65. Line 65.
Oh, yes, opening and open close parentheses. So we're defining something like a cout, except it's not going to the console. It's a buffer in memory. And we're printing to that, just like you're printing to cout, one number followed by a dash, until we get to the null pointer. When we get to the null pointer, we say null pointer, NULL, new line after that. Everything is in the buffer. Right? And then we say, hey, buffer, give me the string version of yourself. And that's a .str call. That's all, okay? Now, the one thing we have to do is go to line 60 and hit enter. What we want to do is if head equals, if open parentheses head equals, head double equals, double equals, null pointer, yeah, all right, yeah. And then on the same line, space, return. No, after the curly, after the open, yeah, return. Or you can do it on the next line too. Yeah, no curly brace, just do a return on the next line. No curly brace, just do, go on the next line. Tab in, yeah, and say return headless list, okay, headless list, and then endl after that. Oh, return headless list with a /n after that. Oh no, just headless list, I think, and that should be within quote. Headless list. No. It's a string. It's a string. So it's 3 words. Headless list. No, 2 words. Headless list. 2 words. And no. So after return, put a double quote. After return, put a double quote. Thank you. Yeah, I should. Yeah, thank you. After return, put a double quote. After the word return, put a double quote. There you go. And then turn that capital H. All right, and then after less space after less, and say list, and then /n after that. Okay, /n. No, \n. Okay, and then semicolon at the end, and then enter. Okay, right. So if the head itself is a null pointer, it's just going to say, hey, I don't know, it's a headless, right? If the head is not a null pointer, it's going to go and say, hey, these are the elements, and it's going to. Does it make sense now? Okay. Now you can actually try this out. You can do a main. Really, let's try it out quickly, because the animation part you can do it yourself, or we'll do it the first thing on Thursday. That's okay too, before we do the game. So let's go to main and test it out. So test out what we got so far. So do a main. Do a very quick main. Int main. No, don't indent in. Why are you indenting in? Yeah, open close parentheses. Yeah, space, curly brace, enter. Yeah, but some more enters and put a return 0 at the end, so that we get some working space, not working on the last line all the time. Right, put some blank lines above that, and then scroll to the middle of the screen if possible. Can you scroll to the middle, or does it stay at the bottom all the time? All right, okay. All right, never mind. All right, so here, what we'll do is create a list. All right, what's the constructor for the list, by the way? Yeah, I say list. Yeah, list my list space my list. No, list, uppercase list uppercase, right? Space my list. You want to do camel case here, but you're doing snake case elsewhere. Yeah. Let's see. Yeah. All right. Okay. List my list, and then that'll call the default constructor. And all right. Okay. Now enter. Right. Now you're going to say for int I equals 1 to 10. Right. So for int, yeah, int I equals 1 to 10. No. So for int I equals 1 semicolon. 0 to 10. All right. What? Yeah, it says 0 to 10. That's much nicer. 0 and I less than 10. That's a condition. I less than 10 is a condition. Yeah, no, not greater than 10. I less than 10. Okay, space I plus plus. Right. All right. Get rid of the. Yeah. All right. Okay. So on the next line, you're going to say my list dot push front I. This is what we called it, push front?
Yeah.
Okay. Hi. Okay, on the next line, enter. And then backspace. Yeah, all right. Now you're going to say, no, not there. Yeah, okay. Now you're going to say C out, left shift. My list. Oh, why is it now indented in now? Left shift, my list dot toString dot toString. Good, great, yeah. All right, open close, and then endl after that. No, you have to do endl. No, not there. ToString does not take any parameters. Yes. So no, ToString, and then open close parentheses, and then left shift, endl. Okay. Right. Everybody should do all of this code all the time until these things just become second nature and automatic to you. Okay. Otherwise, if you're planning to do CS2B and advance along, because otherwise you get a passing familiarity with C++, but really not a mastery of computer science in order to go ahead and do something professionally. These things have got to become automatic and second nature. Like the basic construction of a for loop. And then endl, where should endl go, and and then a function and parameter and so on and so forth. It is just lack of practice, but it is like super important that anyone who wants to go on, whether it's with me or with someone else, also 2B and 2C onwards, or even work in the in the industry, in the software field, these are things that actually absolutely require practice. Okay, especially if you're on an interview and you're trying to code and you're trying to figure out between a while loop and a do while loop on the fly. That actually sends a good signal, right, to the interviewer, saying, hey, that person needs a lot more practice before they can come back and interview here. So those are things that you should just practice up front before you can actually start making making huge things with this. Okay, all right. My list of this. All right, I think you should be able to run it now. At least we should see all the compile errors. Okay, so it is going to, is it running? Is it compiling? All right, we got some errors. What does it say? Oh, it's not uppercase string. It is lower, string is lowercase.
Like this.
Yeah. All right, now compile it, run it again one more time. We'll just see if it's the same error. No, increase the console size. Hey, it actually worked. No, increase the console size. It worked. You see that it worked? Yes. Is it correct?
Yeah, see.
Oh, I see. Yeah. No, hang on. No, something is wrong there. Where does it say 1 and then there's something funky going on there? What is a 0 and the 1 doing there? Okay, all right. So anyway, that it is good. It is good that we have a bug there, and it's a very simple bug. Okay, it's a simple bug. It's a one-off error, something funky there. I know it is going to be simple for me to fix it now. I think it's 744. However, I don't want to eat your cake. I can fix it next class. The first few minutes if you want, but to-do item here. Okay, so put a note on top of the main, right? Saying, oh, on top of the for loop, why does it not print? All right. Why does a toString not work properly? Debug this and discuss in the forums before Tuesday's class. How about that? Yeah. Is that enough of you guys, enough material for you to sink your teeth into? It's a very simple bug, isn't it? It's like, a corner case, not even extra lines of code. You just have to fiddle around there and get it. You have 5 minutes now if you want to try and fix it yourself. We just need to get all the numbers in the right order, right? We started off with a null, and then we printed pushed in a 0 on the head, and then 1 at the head, 2 at the head, 3 at the head. So the list is basically growing like that. And so that's what we're doing. So how about that for the remaining 5 minutes? Let's not do the animation today. We'll do the animation on Thursday. By the way, on Thursday, we should try to aim to complete all of this code. What is it, like 70 lines? All of that in 10 minutes. Try and practice between today and Thursday this code, going from 0 to 60, 0 to 79 in 10 minutes, max of 10 minutes. Okay, you should actually get it in 5 minutes, really. So try and do it. It'll only take 4 or 5 times if you do it. The first few times it's okay if you refer back and say, hey, this is what I need to do. Right? Second time you won't have to refer back. The third time you'll just go from beginning to the end, but it'll take, like, instead of 5 minutes, it'll take 6 minutes. I'll just improve by leaps and bounds. But so do that, and then also fix that error. Okay, and that is going to be a simple error to fix. You can do that now if you want. What else can you do now in the remaining time? Because we're going to do the animation later, right? Next class.
Should that 10 be like an 8, maybe?
No, but still, even then, why does look at the string after 0? It's all screwed up.
After 0, the -1 is caused. Wait, do you want me to say
Oh,
it,
there's
or-
a -1 there. Why is there a -1? No, hang
Oh
on.
yeah, so the reason for that is because our constructor has new node and it takes -1 as the parameter, or like the initializer.
Oh, it's printing the head too. Well, it should not start from head. It should start from head arrow next. I'm sorry. Where's your toString? Where's your toString? Oh, it is starting from head arrow next.
So oddly, if you do node pointer p equals head, then it prints out the first value as well.
Yes, it'll print out the -1. Yes.
No. It prints out the not the first value, it's the last value, I think. Yeah, the last value.
Okay. Anyway, it is very tempting for me to get into this and try and fix it myself. However, I think it's much more fun for you guys to dig into. Yes or no?
Yeah, sure.
Yeah. Okay. Great. Okay. Francis, Richard, who else? I want to see more thumbs up, or people saying yes. So I will dig into it and figure out fix the bug. And it doesn't matter if someone fixed the bug and said this is the bug, and say someone else could say I also fixed the bug. It's the same thing. That's okay. 2 different people talking about the same thing. That's okay. Yeah. In fact, it shows that everybody was able to figure out exactly the same issue. So it's absolutely fantastic. In scientific experiments, when there's a falsification of the theory, then it's important that there's lots and lots of identical falsifications, right? so that you can actually have corroboration or negation of a theory. Okay, all right, fantastic. That's basically it. I don't want to take up any more of your time. Now, we do have 3 minutes. So if you guys want to code on this on your own and debug this together, that's fine too. What else do we need to do here? You can play around more with the list, by the way. You can insert, you can instrument the constructors, okay? Instrument the constructor and the destructor, saying every time you have a new, you can say allocating memory for a new node. And in your destructor, you're going to say deallocating memory. And you should find out that the number of allocating memory shoutouts should be equal to the number of deallocating. So they should match up. Otherwise, you got a memory leak or a memory error. If you're deallocating more than you allocated, then your program will crash. Yeah, so you shouldn't have any of those. The number of allocations should be exactly equal to the number of deallocations. So in your constructor, you can do a cout and saying, hey, I'm allocating some 4 bytes. Or in your push front, you can say I'm allocating memory. And in your destructor, you're going to say I'm deallocating this many bytes, okay? I'm deallocating that many nodes. All of that should print out in your cout. And you'll see that, you got to match up these things, and then you'll see, my program is squeaky clean. It doesn't leak a single byte. Okay, and that kind of security is actually very valuable, because when you know that, you can figure out more complex bugs that are more elusive. Because most of the time, these bugs will lead you astray and stop you from looking at the real problem, and it will go down rabbit holes chasing things. So it's better to get solid on these things, so you don't even have to encounter these issues. Okay, so that's all I have. There's only 1 more minute left in class. If you have any questions, I'm happy to answer them. Otherwise, by Thursday, I'm actually hoping for one of you to volunteer and code up all of those 80 lines in less than 10 minutes. Okay, you just got to go from one of those races, drag races, start 0 all the way up to there. It doesn't have to be like super duper fast. It's going to be like collaborative and say, hey, I'm typing this. All right, typing, all right, curly brace. You can actually type out the whole code while you're calling out the tokens, curly brace, hash include. That's fine. Okay. And it only takes 3 minutes. Everybody is listening to you. Airwaves are occupied. I can hear you. Okay. And it happens in 3 minutes. That's perfectly fine. And then we'll get into the game sooner. And then we'll try and implement something fun with it. Okay. So, and the idea I'm having for next week's game, by the way, is that we're going to construct this large list. Except the last node, 50-50 chance. You're going to toss a random coin, okay? For random, even or odd, okay? So 50-50 chance. You don't even right? If it's 50% of the time, that last node is going to be a null pointer. The other 50% of the time, that last node is going to point to the first node. So in other words, you either have a loop or a ring, or you have a list. Okay. Now the challenge is that you get the pointer passed to the player. Okay, and so this is the beginning of a node, and it's any node, right? Because and you say, is this a list? Are you loopy? Right? Maybe we'll come up with a better name. Are you loopy or something like that? And then we'll give the option of saying, if you hit enter, it's just going to scroll to the left with this animation effect. Okay, and you can keep scrolling as many times as you want. And if it's not a loopy, if it's not a loop, it's got the end. It'll scroll out eventually. Yes. But if it's got a loop, it's going to keep on scrolling indefinitely, right? So you'll never be able to find out. So I think that's a great game. You got to guess by scrolling really fast and finding out if it's a loop or not, and saying yes, it's a loop, no, it's a loop, and you get points for that. I think that's the way it's supposed to work, in my mind anyway. We'll see if it works, okay, and we'll see if it's interesting. But I think it's fun because it'll give the people the opportunity to have this animation play out, and also take, visually say, hey, are those numbers repeating or not? Okay, so it's a challenge for, visual tracking as well as remembering the patterns in the numbers. I think it'll be fun to do. Just like the stack game, it's fun for memory jogging. Yeah. So this will be fun too. And I think that'll be the last, we'll wrap up the quarter with that. And then I'll also be happy to answer any questions that you have about the final next class. All right. Was this, you got this is not complete, by the way. Okay, somebody's got to all of you've got to fix that bug and share this and talk about this. And by the way, Jesus, you should share this code in the forum and also put a paragraph with the link saying this is what we did, and there's a bug in this thing because it does this instead of that, which is supposed to do. Please, everybody should try and fix this and share the fixed versions. Okay, so you should say that in the forum, not in the chat. Okay, you should do that in Reddit. Right. So thank you. Was this useful and a fun class for you guys? Yes or no? Right. Did you
Yeah.
guys, yeah. All right. So if you learned something new, that is absolutely fantastic. The class never goes waste when something new has been learned, right? For all of us, all the time. So I hope to see you all on Thursday again, one more time, before the end of the quarter. Otherwise, happy questing and happy hacking. Okay, and take this to the next level, and we'll see more of this on Thursday. Okay. All right. See you guys later. Bye.
So I just had a quick question regarding
Yeah,
2B.
sure. Go ahead, Jin.
Yeah, so it's gonna be like completely online.
What is going to be completely online? Oh,
Your
the
2B
final?
class for the
Yeah,
summer.
just the final.
No, no.
Final is just like the midterm.
Oh no, the 2B class for summer.
Oh yeah, completely online. Actually, Caitlin is in 2B. You can ask her too. Yeah.
Oh, so is it gonna be like based on the quests, I guess?
It's going to be homework is going to be homework's all going to be the quests, and the quests basically cover every single thing that's in the syllabus. I think 90% of the stuff in the syllabus is covered in the quests. And we still have material from the previous professor as modules to study. You have the textbook as well as all the recommended hot topics for the week in Canvas. We just won't have meetings like this unless
Right. So
unless we arrange this. You guys, I'll arrange Zoom meetings every week for you guys to meet. And I'll attend any of those that you invite me to.
oh, all right, cool. All right, thank you.
All right, no worries.
Hi, Professor. I just want to say I accidentally dropped out the class.
When?
Because my computer crashed.
Oh,
Ran out of battery, didn't realize.
dropped out of
Yeah.
today's class.
Yeah.
That's okay. Yeah. And you can keep doing your own cool projects too, like this a Mandelbrot thing you're doing, and all of those things are really cool. Coming up with your own ideas, I
Yeah.
think it's more valuable than if the professor says, "Hey, here's an idea you should work on." Yeah, if you're stuck for ideas, which is usually bad, which is usually not the case, because students usually have more ideas than professors in things, because you have more exposure to lots and lots of things that are happening and hot. So you may have ideas that if you're stuck for them, you can just email me and I email you a couple of things that you can try. Okay. But you don't need to worry about extra credit and grade and things like that. You've been doing really well so far. Yeah.
Yeah, I just saying like it would be better because I can make up for the points I lost on the first quiz.
No, don't worry about that. Right? You've been doing great so far in class.
Okay.
Yeah, all right. So don't worry about it. But just do all these things that you're doing, right? Like Richard is also doing. You just pick up these ideas of your own and just noodle on them. And it's fun. Because you have to develop a taste for it, yes? Lots of food. Lots of food, really, really cool food. And very interesting and useful, nutritious food that we have to get used to tasting.
Yeah.
All right, okay. See you later. Bye.
Bye.
Bye.